faster than the surface of spacetime can remain mindful of it. It will essentially tear, and I'm terrified by this. By and by, our night sky is changing rapidly, and in just an issue of numerous years, if not sooner, it could become unrecognizable. Cosmologists are sounding the alarm. Experts like Neil deGrasse Tyson have confirmed the inevitable impact of Polaris, and the story behind it is extremely surprising. Polaris, known as the North Star, has long been a constant in our night sky, serving as a critical reference point for stargazers, navigators, and astronomers. However, this could soon change, altering our night sky and our understanding of the cosmos. Let's dive into the significance of this threat and its implications for all of us. Join us as we uncover the story of Polaris as it nears its end. For centuries, Polaris has guided mariners and stargazers alike, holding a revered position as a guiding light. Its steady presence in the night sky has been crucial for navigation. However, this stability may soon be disrupted. In September 2023, a research paper presented by the esteemed Royal Astronomical Society cast doubt on the fate of this celestial illuminator. Polaris is on the verge of exploding, potentially disappearing from the night sky forever. Before we explore the consequences of this revelation, let's understand more about Polaris. Also known as the North Star or Pole Star, Polaris is unique due to its proximity to the celestial North Pole. Positioned almost directly above Earth's North Pole, it appears nearly fixed in the northern sky. Found in the constellation Ursa Minor, the Little Dipper, Polaris shines as a relatively bright yellow-white supergiant star, much larger and brighter than our Sun. Interestingly, Polaris is not a single star but part of a complex triple star system. Polaris A and Polaris B form a binary pair, while Polaris B orbits around them. The interactions between these stars create gravitational forces that shape their orbits and influence their behavior. Any disturbances in these interactions can lead to unpredictable variations in the star's brightness or pulsation patterns. However, the exact mechanisms behind these interactions remain unclear. Polaris is located approximately 323 light-years from Earth, meaning the light we see from it today began its journey centuries ago. Thus, if Polaris were to explode now, we wouldn't observe it until over 300 years later. The fact that Polaris has survived this long makes it possible that it has already exploded, and we are yet to witness the light from that event. Since ancient times, the North Star has held tremendous cultural, navigational, and symbolic significance. Its stability and fixed position made it a vital guide for ancient sailors, helping them navigate across seas and lands. Symbolically, Polaris represented steadfastness and direction, remaining unchanging amidst the ever-shifting night sky. For astronomers, Polaris served as a crucial reference point in the study of celestial movements and variable stars. As a Cepheid variable star, its periodic variations in brightness provided valuable insights into stellar properties and the nature of variable stars. These characteristics also played a significant role in determining cosmic distances and calibrating instruments. Polaris's pulsations follow a predictable pattern, which has been the standard for the star, making its behavior relatively easy to anticipate. However, in recent years, Polaris has deviated from this typical behavior. This anomaly in its pulsation cycle has baffled astronomers, prompting closer examination of this celestial irregularity. Rather than its usual predictable pattern, Polaris has begun to exhibit inconsistent periods of dimming and brightening. Experts are now raising concerns that the star might be nearing the end of its life. This aligns with behaviors commonly observed in stars approaching the final stages of their life cycles. The gradual lengthening of Polaris's pulsation period, which was once stable, can be attributed to interactions within its stellar system. Researchers have observed an annual increase in the pulsation period of 4 to 5 seconds. While this change may seem minor, it holds significant implications. Some space scientists suggest that gravitational interactions between the Polaris stars could be causing these changes, directly affecting its pulsation patterns. Others are more alarmed, believing that the star is perilously close to exploding. The similarities between Polaris's behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have exhibited puzzling anomalies in their luminosity, raising concerns about potential supernovae. Red supergiant stars in their twilight stages often display such irregularities before reaching the end of their life cycles. While NASA has expressed heightened concern about Betelgeuse, similar attention has not yet been formally directed toward Polaris. As a red supergiant star approaches the end of its life, it undergoes various phases, including the main sequence, red giant stage, and finally a supernova explosion. Based on Polaris's unpredictable pulsations, researchers predict that it has entered the helium-burning phase typical of stars nearing their end. These anomalies in Polaris's behavior align with patterns characteristic of supergiant stars in their twilight stages. However, definitive signs of its imminent supernova remain uncertain. Astronomers are continually studying these irregularities to determine Polaris's fate. If Polaris were to go supernova, it would likely be a spectacular event in our sky, possibly outshining the Moon and becoming one of the brightest objects visible for weeks or even months. Its appearance could drastically alter the night sky, momentarily changing our perception of familiar constellations, such as the Big Dipper, of which Polaris is a part. Rest assured, Earth would likely remain entirely safe even if Polaris were to explode, given its mass and distance from us. While a Polaris supernova might not be as visually dramatic as Betelgeuse, it could still be visible to the naked eye for an extended period, overshadowing nearby stars. Astronomers and observatories would undoubtedly take notice, sparking interest within the academic community and among stargazers worldwide. However, the specific visibility and impact on Earth's environment or atmospheric conditions would be less significant compared to a closer supernova event. Let's clarify one thing. While massive stars often end their lives in a supernova explosion, this is unlikely to be the exact case with Polaris. When a massive star goes supernova, it typically leaves behind either a neutron star or a black hole. However, Polaris's mass, although substantial, may not be sufficient to produce these extreme remnants. Instead, Polaris is more likely to shed its outer layers in a less dramatic process, potentially forming a planetary nebula. This beautiful remnant would consist of glowing gases, illuminated by the star's core, which would eventually cool and shrink into a white dwarf, a dense, dim star about the size of Earth. Even so, a supernova or any significant transition in Polaris's life cycle would have major implications for our understanding of stellar evolution. It would provide astronomers with valuable data to refine models of how stars live and die, particularly those in binary or multi-star systems like Polaris. The broader impact on our night sky would be equally profound. Polaris has served as a constant reference for navigation and astronomy, symbolizing stability and direction. Its loss would require recalibration of celestial navigation techniques and adjustments to instruments reliant on its position. Culturally, its disappearance might also mark the end of an era, as humanity loses a star that has been a guiding light for millennia. In the grander cosmic context, Polaris's journey serves as a reminder of the impermanence of even the most steadfast celestial objects. The universe is ever-changing, and stars like Polaris, despite their apparent immutability, are constantly evolving. While the prospect of losing such a significant star may seem daunting, it also offers an opportunity to witness the remarkable processes that shape the cosmos. For now, astronomers continue to observe Polaris closely, monitoring its pulsations, brightness, and behavior. The question of whether we are nearing the end of its life, or witnessing a temporary anomaly, remains unanswered. However, one thing is certain. The story of Polaris is far from over, and its legacy, both scientific and cultural, will endure long after its light has faded. In the meantime, we can look to the skies and appreciate the beauty and mystery of this iconic star, marveling at the intricate dance of forces that govern the universe and shape our understanding of it. Whatever happens to Polaris, it will forever remain a symbol of humanity's connection to the cosmos, a guiding light in both a literal and metaphorical sense. A huge blast happens inside it, denoting the last disastrous stage in its life. This cycle includes a total breakdown of the center, setting off a monstrous shock wave that makes the star detonate brutally. Anyway, Polaris isn't sufficiently enormous to go through such a blast. Rather, when Polaris depletes its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This change won't result in a supernova explosion, but rather a calm end as it evolves into a small, staggeringly dense stellar remnant. A white dwarf is the remainder of a low or medium-mass star that has exhausted its nuclear fuel. It is extraordinarily dense, likely as massive as the Sun but compacted to the size of Earth. When this happens, we can no longer see its remnants from our planet in the same way we observe the star today. Comparing the potential impacts of Polaris N to historical supernova events provides valuable insights into the evolution of stars and their ultimate destinies. For instance, contrasting our expectations with real observations, such as SN 1987A and later events like SN 2011 Fe or SN 2014 J, offers crucial data for understanding Polaris' possible outcomes. SN 1054, for example, led to the formation of the Crab Nebula, a cloud that continues to expand and emit radiation across various wavelengths, offering astronomers a rich field for study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, provided insights into nucleosynthesis processes and the properties of supernova remnants. Features like nebula formation, cosmic ray release, and variations in brightness can reveal Polaris' unique characteristics. The formation of nebulae, such as the Crab Nebula, occurs when material ejected during the supernova interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of stellar birth and death. Furthermore, the release of cosmic rays, high-energy particles accelerated by the supernova shockwave, has implications for astrophysical processes and cosmic radiation environments. To draw accurate comparisons, researchers analyze various aspects, such as mass, composition, and speed of ejected materials, between Polaris' expected burst and other observed events. This involves examining light curves, spectra, and remnants of these events and projecting similar attributes for Polaris' potential end. Assessing whether Polaris' explosion could result in nebula formation or specific elemental distributions enhances our understanding of its probable outcomes. Another critical area of study involves analyzing the pulsational variability of stars nearing their end stages, such as Polaris, compared to observed supernova progenitors. Close examination can help verify similarities or deviations, providing insights into the explosion mechanisms. Pulsational variability in stars approaching the end of their lives may indicate internal instabilities or imminent catastrophic events, offering clues about the evolutionary processes leading to supernova explosions. Despite careful observations and extensive analysis, astronomers remain puzzled by anomalies observed in Polaris behavior. Deciphering the complex conditions driving these irregularities holds the key to advancing our understanding of stellar evolution. Understanding the forces behind Polaris' erratic pulsations requires interdisciplinary collaboration and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a vital reference point in the night sky presents significant concerns for astronomical endeavors. Ground-based telescopes and celestial measurements would require recalibration, affecting the accuracy of cosmic assessments. The absence of Polaris could also impact navigation systems and cultural practices based on celestial landmarks, highlighting the importance of this stellar event. The complex behavior exhibited by Polaris underscores the need for deeper investigations and dedicated research efforts. Astronomers must grapple with the intricacies surrounding its unpredictable pulsations and present concrete answers. Recognizing the significance of advancing our understanding, we may eventually unravel cosmic complexities. Ultimately, the fate of Polaris remains uncertain, and only time will reveal its true essence. Nonetheless, the quest for knowledge and understanding in the face of infinite uncertainty is a testament to humanity's enduring curiosity in unraveling the mysteries of the universe. As we contemplate Polaris' destiny, it is essential to recognize its role not only as a celestial marker but also as a window into broader cosmic phenomena. The North Star has been pivotal in expanding our understanding of the night sky. Ancient cultures used its position to develop calendars and seasonal agricultural practices, linking celestial events to natural activities. As civilizations advanced, Polaris' stable position provided navigational aids that facilitated exploration and trade, marking it as a cornerstone of maritime history. In modern astronomy, Polaris serves as a vital alignment point for telescopes and observational instruments. Its consistent brightness has allowed astronomers to refine their measurements of distances across the universe. The star's predictable light output contributes to the cosmic distance ladder, a crucial tool for measuring distances to distant galaxies and understanding the expanding universe. Interestingly, studying Polaris also opens avenues for examining stellar evolution. By analyzing its life cycle, researchers gain insights into the broader life cycle of similar stars. The properties of Cepheid variables, including their pulsation periods and luminosity variations, allow scientists to draw comparisons with other stars, enhancing our understanding of stellar characteristics across different stages of life. As we examine the final stages of a star like Polaris, we must also consider the implications of its potential transformation into a white dwarf. This process is a fate shared by many stars in the universe, leading to the formation of stellar remnants that will persist for billions of years. The study of white dwarfs has significant implications for understanding stellar and cosmic evolution. Additionally, the interaction between dying stars and their surroundings is a fascinating area of study. When stars shed their outer layers, they enrich the interstellar medium with heavier elements formed through nucleosynthesis during their lifetimes. This recycling process is essential for the formation of new stars, planets, and, ultimately, life itself. By examining the remnants of stars like Polaris, scientists can trace the pathways of matter throughout the universe. The potential explosion of a star like Polaris raises questions about its impact on the surrounding cosmic environment. While its distance from Earth provides a layer of safety, the energetic phenomena associated with supernova events, such as shock waves and high-energy particle release, can influence nearby star formation processes. This could lead to bursts of intense star development or trigger the collapse of gas clouds, resulting in the birth of new stellar systems. Beyond its scientific implications, the story of Polaris also raises philosophical considerations about humanity's place in the universe. As our understanding of cosmic life cycles evolves, we are reminded of the transient nature of celestial bodies. Just as Polaris has guided humanity for centuries, its eventual transformation will mark a change in our night sky, serving as a poignant reminder of the inevitable changes that permeate the universe. Astronomy has often inspired questions about the fate of our planet and species. As Polaris approaches its potential end, it prompts us to reflect on our own existence and the legacy we leave behind. The pursuit of knowledge about stars like Polaris fosters a sense of wonder and curiosity that transcends generations. Finally, advancing observations and breakthroughs in technology will allow astronomers to monitor Polaris more closely than ever. Upcoming telescopes and space missions are designed to capture unprecedented details of celestial behavior. These observations will not only shed light on Polaris' life and death, but also deepen our understanding of the broader cosmos. In conclusion, the story of Polaris extends far beyond its visible presence in our night sky. It embodies centuries of human exploration, serves as a critical benchmark for astronomical measurements, and invites us to ponder deeper questions of existence. As we watch the fate of this beloved star unfold, we engage in a larger narrative about the universe, a story that continually shapes our understanding of life, time, and the cosmos itself.